at our insulation. Now these are just some key factors: costly repairs after the warranty's out, and the overall install costs a bit more. So if we look at the cost breakdown. Hey everyone, welcome to episode 1. In this episode, we're gonna dive in on how we take all the measurements from your house and size it to come up with the proper calculation for the proper size of your HVAC equipment. So whether that's your furnace, your air conditioner, or your heat pump, we need to understand how and what goes into this calculation to ensure that your house works as efficient as possible. Why does it matter? If my furnace is too big, then what? I'm gonna have higher energy bills and it's not gonna work properly. If my furnace is too small, my house is gonna be cold. Here in Ottawa, we deal with extreme temperatures. We go down to -30, we go to +30. So at those temperatures, my house is gaining a lot of heat, it's also losing a lot of heat. So outdoor factor plays a huge role in this. So let's dive in and have a look at that. So let's look at the building envelope. And what I mean by building envelope, I mean your house. So what are the key factors that go into us losing heat or gaining heat? So we're gonna look at our insulation, okay? So whether that is in the attic, in the walls, or even your basement slab. We're also gonna look at your windows, and these play a key role as simple as which way are they facing? Are they facing south facing? Are they north facing? This actually plays a large role in how much gain your windows get. Also, how much heat they lose could be dependent on the design of the window itself. We look at the doors, how well are they built and insulated, and we also look at how many people are in the house. So occupants. Now these are just some key factors going into what we look at when we do a design. We could also look at how many electronics you have. Do you have an older fireplace, a newer fireplace? Is it sealed? Is it not sealed? Again, this is just brief to show you what actually goes into sizing your house when it comes to looking for the proper furnace for your house or the proper air conditioner. So if we flip over, we can see I've got 2 houses. And let's say in our top house, this is where we lose heat. So heat loss. So on this house, I'm gonna lose heat from a lot of different factors. Is my attic well insulated? How much heat am I losing from my attic? More of the insulation, the less heat I'm gonna lose. My windows, I'm losing heat from my windows. When we install windows or windows are installed, are they sealed around them? What's the design of the window? Are they newer windows? Are they older windows? This is gonna depend on how much heat we're gonna lose through them. We're also gonna lose heat through our doors and also our walls. So that comes up to insulation values. How well is my wall insulated? How much heat am I losing through it? When it comes to heat gain, that's when the solar really takes over. So we have heat gain, and we're gonna have to look at factors such as, is my roof dark? Does it see sun all the time? How well is my attic insulated? How much heat am I gaining through my roof? My windows, do I have shading on my windows? Which way do they face? Are they south? Are they west? Are they north facing? This all comes into play when we're sizing out our air conditioner to see how much solar gain we receive. We also receive heat through our walls, although minimal, we still do. So where do we go from here? If you have a new house or a new build, you're probably gonna have a set of floor plans, architect design. It's gonna give you all the values you require. So my insulation values for my attic, my insulation values for my walls, etc., window design. This is gonna be sent to an HVAC designer, which is gonna give you a set of HVAC plans for that new build. But if your house is older and you don't have this, or you don't have a set of plans, we can run our own calculation to best determine what's needed for your house. So it would look something like this. A not to scale drawing by myself to give you an example of what your house would look like on a set of plans. So if you look here, I've got the basement, I've got the main floor, and I've also got the second floor here. So in my basement, I've got my mechanical room, probably the most important part of the house. I've got my garage, which actually eliminates part of my basement square footage. And then along with on my main floor, I've eliminated some of my main floor square footage as well. So if we look at this, I've cut down each room. I've got my little dots here to separate the sitting and the dining room because we love open concept. Same with my living room and my kitchen. But each room is actually measured out properly from point A to point B. And I've also got all my window sizes, and to the best of my knowledge, based on when your house was built, I'm gonna do the best to determine what is the R value inside your walls. Maybe you know that, maybe you've done upgrades, maybe you have changed your windows lately and you have some data on that. I'm also gonna get what is the R value in your attic. Again, maybe you've had that done recently and you have that, but if you don't, we can kind of refer back to the Ontario Building Code to get the best idea of where your insulation is based on the year your house was built. So now that we've got all of our measurements, we know the window sizes, we can actually put this into a software, which is a HVAC calculation software. It'll actually give us some numbers. So let's have a look and compare 3 different houses. I used the same footprint I had here, and I just plugged in different values for different insulation to give you different BTU values. So house number 1 was built in 1990, house number 2 is built in 2010, and house number 3 was built in 2024. So if we look at this, obviously we're gonna have not as good of insulation in the house that was built in 1990. You can see our insulation values here. So wall values are 12, attic value are 30, windows are single pane. So we come up with a final tally for a heating BTU of 56,231 BTUs required for that house to maintain its heat. And if we look at our cooling data, that is 22,000 BTUs, 923. As you can see, as our house becomes more efficient, so now we go into 2010, we have an R value in the walls of R22, R50 in the attic, we have double pane windows, and we actually managed to take off 16,000 BTUs almost, bringing our total heating load down to 40,553 BTUs, and our cooling down to 18,807 BTUs. Flash forward to 2024, our insulation values have increased to R28 in the walls, R60 in the attic, triple pane windows, which now brings our heating load down to 35,039 and our cooling load to 17,826. So what does that mean? As we increase the insulation values and our houses became more efficient, we actually decreased the amount of heat and cooling required to keep up with our house, which means lower energy bills for you and more efficient equipment. So just for fun, I'm going to pull out my phone here and I am going to see if we have a rule of thumb on how to size heating equipment. So how do I size my furnace for my home? We have come up with a rule of thumb anywhere from 30 to 60 BTUs per square foot. So if we look at what I just put in on my drawings, it's about 2,000 square feet, give or take. So let's add those numbers in. So 30 to 60. 30 being in warmer climates, 60 being in colder climates. So because we're in Ottawa, it's typically colder. So let's just be generous and maybe we'll go with 50. So let's say 50 times the square footage comes up with 100,000 BTUs. This is why it's important to have the calculation done properly so you're not oversizing your equipment. If I go with 30, maybe the lower end, it is 60,000, which is very close to my number. But as you can see, if I use that low number and I use 60,000, I'm actually oversizing my furnace on my last house. Again, always important to understand the numbers and what goes behind the scenes in calculating your HVAC, and really important to have a professional come out and do this for you. Thank you everyone for watching episode 1. Hope you stay tuned for episode 2. Coming out next, it's gonna explain, now that we've got this calculation, what equipment do we choose? If you wouldn't mind liking, sharing, and subscribing to this channel, that would be fantastic. Thank you so much.